Okay, this was my high school computer science project. Well, it was one of them. And if you've read on my blog, I've been trying to port a number of those projects from the Turbo Pascal 3.0 compiler that they were written for back in 1988, 1990, 1989 to run under the Free Pascal compiler. So these ones are problematic because they're graphics. The graphic style that gets used on this project, as well as a couple others that I wrote, is based on what's called turtle graphics, which if you ever use Logo is like Logo, that kind of language. You kind of move like a little turtle around on a screen kind of thing. But this was a Pascal version of that library. It wasn't really called that in the documentation that I read, but that was what it was. So modern graphic systems don't work like that. So learning how to port that over, I'm not a graphics programmer, will be an entertaining task. I have managed to port over pretty much all the text mode ones, and they're rather simple. Now, interestingly enough, one of the things is you see a little bit of writing on there, not the cursive velveteen bit. That was the splash screen was based off of a children's book that I liked, and obviously the background graphics are Sierpinski gaskets. It was 1989, and what was it? James Gleick had that book, Chaos Theory, that we were, well, all math geeks were busy reading. So, but anyway, so not that text or the graphics, but the other text, the software productions and the presents and all that sort of thing. That's all just kind of done with the same text-based API to move text around on a screen in non-graphics mode. So it was kind of a combined thing. This is CGA with all of its glorious 4 colors. You had a number of different color palettes. So for this one, it's green, red, yellow, and black. So when we go into the game, which I'll do now, you'll see that I've changed the color palette, and it's purple, cyan, black, and white. Another popular thing at the time was war games. So if you've ever seen war games, the thing with the code being guessed, that's clearly what inspired my font and the animation that was going on up there. Now I'll just have the computer play first. The computer never is able to beat itself, and the games go pretty quick. So my goal there was to have the board spin out, but I think the big problem that I had was I made the lines the same length. They filled the square where it was, and they should have been smaller, and that would have done what I had wanted. I hadn't figured that out back then, but kind of watching it the past few days as I've been kind of learning how to do different pieces for the porting. And that's very clear that was what was really messed up about my animation. I thought it was how far apart the things were, and that wasn't really it. Anyway, so I might try and clean that up. The X's and the O's are drawn. It's again, it's like Turtle Graphics, so you just draw the outline of the shape, and then there's a way to fill a space. So that's how the X gets done. The O, I kind of cheated. What I did was I drew. It's just the math was hard. I'm not a graphics programmer. I really was not a big fan of the math to figure that out. But finding your fill point was a little bit difficult with the circle. So what I just did was I filled the middle of the circle, and it would fill it all in, and then you'd end up with a big round white thing, and then you'd draw a black circle in, and you'd fill in the middle. It would fill it in. The fill algorithm was imperfect. So if I tried to draw the outline of the character and then do the fill, there would be little bits where it hadn't filled in properly. So it was just quicker to do it that way. You see a little bit of a flash on this. The flash was a little bit worse on the original computer it ran on. A lot of these things are sped up. It's an emulator, so it tries to kind of do the older ones, like the speed wise, but the reality is even the emulator's faster than the old computers were. So, all right, so now we'll try seeing a single person play. The reason why I show this is just because I thought the algorithm that I had come up with would make so the computer always wins, and that's an entirely plausible outcome for writing a tic-tac-toe playing algorithm. It's eminently achievable, but not to 17-year-old me, as it turned out. So, and the key here is that when I go to play, is first you have to go first. That's a given. But I did make it so that it wouldn't lose if you went second. That would be really sad. But or at least I hope I did. But the key is not to start in the middle, which is the normal place you should start to win a tic-tac-toe game, or at least that's my understanding. It's to start on one of the sides. And it goes to the middle. That makes sense, but that does not make sense. It should try and go in between the axes, and instead it just kind of randomly picks a side spot. And there actually is something there in the code that essentially says if there's nothing to block, then go try and get one of the middle squares, which in this case is an unfortunate response. So if I go here, obviously, now it can't block two spots. So I win. Unfortunately, I think I can't remember exactly, but I think I bet $10 that it couldn't be beaten, and there was one other kid in class who sat down and beat it on the first try, if I recall correctly. So that was expensive, and it was a good learning experience that users sometimes behave in ways that you don't expect, and they come up with outcomes that you don't expect. So early learning of that, which obviously is a continual lifelong learning process for software developers. Anyway, that's the extent of it, I think. Yeah, the issue is, like I said, it's the graphics format. The graphics API is this Turtle graphics API, and there are certain versions of it that you can use, that sort of thing, on Pascal, or free Pascal at least. But from the research I've done so far, they're kind of all imperfect. So I'll have to write pick a graphics library that does work. I kind of want it to work on OS 10 and on Linux. So it has to be one that's portable between the two. And then just write some sort of a shim to essentially do the turtle graphics and get that working. And then it'd be nice to fix the animation. So, and then maybe we could explore beyond 4 colors. That could be exciting. So, all right. Thanks for watching.